Hi, my name is Gabe. For this problem, we're asked to plot the complex number 1 minus the square root of 3i, and then write the complex number 1 minus the square root of 3i in trigonometric form. Let's begin by plotting the number 1 minus the square root of 3i. We know that we'll move 1 along the real axis, and we'll move down the square root of 3 on the imaginary axis. And since the square root of 3 is approximately 1.7, our point, 1 minus the square root of 3i, will be approximately here. Next, we'll want to convert this number into trigonometric form. So let's recall that if we have any imaginary number, z equals a plus bi, we can convert this into trigonometric form, which is r times cosine of an angle theta plus I times sine of the angle theta, where we have that r is equal to the square root of a squared plus b squared, and r is also called the modulus, and we know that tangent of theta is equal to b divided by a. And here we call theta the argument. So let's take our complex number, z equals 1 minus the square root of 3i, and let's begin by finding the modulus. So r in this case is the square root of 1 squared plus the negative square root of 3, quantity squared. Now this is equal to the square root of 1 squared, which is 1, plus the square root of 3 squared, which is 3, which is the square root of 4. And we know that the square root of 4 is 2. So our modulus is 2. We also have that tangent of theta is going to be equal to negative square root of 3 divided by 1. So tangent of theta is equal to the negative square root of 3. Now here, we can use the inverse trigonometric properties to solve for theta, and since we're in the fourth quadrant, we'll have to add 2 pi to our number. So we have theta is equal to arctangent of negative square root of 3 plus 2 pi. And we have arctangent of negative square root of 3 is negative pi over 3. And we're adding 2 pi. And when we do this, we find that our argument is 5 pi divided by 3. So we can rewrite our number, 1 minus the square root of 3i, in trigonometric form as z is equal to our modulus, 2, times cosine of our angle, 5 pi divided by 3, plus I times sine of our angle, or our argument, which was 5 pi divided by 3 again. So here's our number written in trigonometric form. Now if we come back to our point which we plotted, if we interpret what the modulus is and what the angle is, what we see is the distance from the origin to our point is our modulus, which in this case is 2, and the angle in standard position that intersects this line is our argument. So we found this to be 5 pi divided by 3. Thank you.